find the length of the tunnel, we need to find the length of this hypotenuse first. So we know in this right triangle, sine of 4.962 degrees is equal to opposite over the hypotenuse. So 196.8 divided by c. And then we multiply both sides by c. We get c times sine of 4.962 degrees equal to 196.8. Then we divide both sides by the sine of the 4.962 degrees. Then we get c equal to 196.8 divided by sine of 4.962 degrees. And this is approximately equal to 2275.2754 feet. Then the length of the tunnel is equal to 2 times c, so which is approximately equal to 4550.55 feet. Done. Now let's look at the problem 52. And this is a little bit hard. So a forest ranger atop a 32-48 feet mesa is watching the progress of a forest fire spreading in her direction. Okay, so let's first draw the sketch. So this is the problem 52 on the page 498. And first, we have a ranger at the top of a mesa. The height of this mesa is the 32-48 feet. Then, in 5 minutes, the angle of depression of the leading edge of the fire changes from the 11.34 degrees to 13.51 degrees. Now, it asks, at what speed in miles per hour is the fire spreading in the direction of the ranger? So now let's draw these two angles of the depression. So let's first draw the horizontal line, right? Then first you have an angle of depression like this. So this is the ground. Okay. And at the first, the angle of depression is the 11.34 degree. Let me call this alpha. And after 5 minutes, the angle of depression changed to 13.51 degrees. So this is the second angle of depression, and this angle is the 13.51 degree. Let me call this beta. So by the knowledge of the geometry, the plane geometry, we know this is alpha, right? This angle same as this angle. And then this is beta, same as this 13.51 degrees. So now, first, we need to find this distance. And this is the distance that this leading edge of the file cover in the 5 minutes. Then we divide this distance by 5 minutes, then we get the speed of this leading edge of the file. Okay. So let me call this point A, and this the point B, and this point C, and this point P. Okay. So the distance D, that should be equal to the AC minus this AB. Right? And then we just need to find the AC and this AB in terms of this AP. AP is equal to 3248 feet, right? And then we get the D. Then we divide this D by the 5 minutes, then we get the speed. So first, let's look at the AC. To find the AC, which function should I use? Which one? See, this is the AC is adjacent of the alpha, right? So you may try to use the cotangent. You have the cotangent alpha, which is equal to AC, this is the adjacent, over the opposite 3248, right? And similarly, you can use the cotangent beta, which is equal to AB over this 3248. Now you multiply both sides of these equations by the 3248. You get AC equal to 3248 times cotangent alpha, and AB is equal to 3248 times cotangent beta. And then D is equal to AC minus AB, then which is equal to 3248 cotangent alpha minus the 3248 cotangent beta. So this guy, plug in the values of the alpha and beta into this expression of 3248 times cotangent of the 11.34 degrees minus cotangent of the 13.51 degrees. Then use the calculate compute. You get the distance between the B and C, which is approximately equal to 2666.91 feet. Okay, and then let's change this to the miles. So this guy approximately equal to 2666.91 over the 5280 miles. Okay, because 1 mile is equal to 5280 feet.